tardes a todos y a todas y bienvenidos a el Seminario Internacional de Biodiseño y Nuevos Métodos de Manufactura. Es un honor darles la bienvenida a la UDD, a quienes nos acompañan acá presencialmente y a quienes se van a poder conectar a la transmisión que tenemos en vivo vía Zoom y UDD TV. A este evento que simboliza nuestro compromiso permanente en torno a la interdisciplina, la tecnología y a la innovación. Hoy vamos a poder compartir experiencias con un socio internacional de primerísimo nivel, la Universidad de California con su sede de Davis, en un intercambio que se basa en una semana de actividades que hemos denominado la Semana UDD del Biodiseño y la Industria, que cuenta con diversos eventos y discusiones en torno a las nuevas tecnologías aplicadas a las disciplinas, en particular de la ingeniería y el diseño, con foco en esta que hemos centrado la conversación hoy, denominada el biodiseño, disciplina o subdisciplina que conecta a el diseño y la ingeniería a partir del desarrollo y la manufactura con materiales nuevos de origen biológico. Quiero comenzar saludando al rector de la Universidad del Desarrollo, señor Federico Valdés, al decano de Ingeniería UDD, señor Fernando Rojas, y a las distinguidas invitadas de la Universidad de California, Davis, la doctora Christina Cogdell, Professor and former Chair of the Department of Design, PhD in Art History at the University of Texas, Austin, y especialista en biodiseño, y a la doctora Valeria La Saponara, Professor and Vice Chair of Undergraduate Studies of the Department of Mechanical and Aerospace Engineering, PhD in Aerospace Engineering de Georgia Tech y especialista en biomateriales. La adopción acelerada de nuevas tecnologías se manifiesta todo el tiempo. Este año pudimos ver cómo desde comienzos ChatGPT irrumpió con una velocidad y una intensidad muy importante que nos hizo repensar, redibujar y cambiar la manera en cómo hacíamos muchas cosas y afectando muchas dimensiones de nuestras vidas, el cómo trabajábamos, el cómo aprendíamos, etc. Este tipo de fenómenos, como ejemplo, la UDD ha estado buscando reconocerlos, anticiparlos, con diversas iniciativas en los últimos tiempos. Y ExploraTec, como su centro de exploración tecnológica de las facultades de diseño e ingeniería en todas las sedes de la UDD, ha estado especialmente volcado en ofrecer a estas facultades y al resto de la universidad un proyecto formativo interdisciplinario con un modelo distintivo para integrar las disciplinas y esto es muy importante, utiliza a la tecnología como piedra angular para la interdisciplina. Y tenemos ese planteamiento de la tecnología como piedra angular de la interdisciplina si uno considera que la interdisciplina implica sumar técnicas para resolver algo, y sumar técnicas para resolver algo es una manera de definir a la tecnología justamente. ExploraTec hace interdisciplina en torno a la nueva manufactura, que es la línea tecnológica que vamos a discutir hoy, y a otras tecnologías como la inteligencia artificial, las ciudades inteligentes y la realidad virtual y aumentada. Soy Nicolás Goluboff, director de ExploraTec, y los voy a guiar a través de este seminario. Les recuerdo que el evento se está transmitiendo en vivo por Zoom y UDD TV y cuenta con interpretación simultánea inglés-español. A continuación vamos a dejar con nosotros al rector de la UDD, el señor Federico Valdés, a quien invito al podio para darnos unas palabras de bienvenida. Muchas gracias.
Buenas tardes. Nuestra perspectiva es clara. Entendemos la formación interdisciplinaria como la interacción efectiva entre diversas áreas del conocimiento, y subrayo efectiva. No se trata solo de tener estudiantes de diferentes disciplinas en una misma sala, sino que diseñar experiencias de aprendizaje que integren conocimientos de múltiples disciplinas para aprender a integrarlas. La interdisciplina no puede ser una simple declaración, porque suena bien marquetero, suena como muy elegante. Es un imperativo para abordar los problemas complejos y globales que enfrentamos hoy. No se limita a la colaboración de investigadores de distintas disciplinas, sino a resolver problemas con enfoques metodológicos y conceptualizaciones diversas, ya que los problemas más complejos no son confinables a una disciplina en particular. Las disciplinas tienen, por supuesto, ángulos ciegos, y la interdisciplina ayuda a evitar esos ángulos ciegos. Estamos comprometidos con que la interdisciplina sea un componente esencial de nuestra identidad institucional, y por ello, uno de los pilares de nuestro proyecto educativo UD de Futuro lo constituye este elemento. Estamos decididos a llevar la formación interdisciplinaria a todos los niveles de la formación que entregamos a nuestros estudiantes. Así, desde los primeros años, les toca participar en actividades y cursos interdisciplinarios para enfrentar tempranamente el desafío de la colaboración. No solo buscamos diálogos multidisciplinarios, sino un aprendizaje entre diferentes carreras en niveles básicos, intermedios y avanzados. Este seminario se enfoca en elementos centrales de nuestro proyecto universitario. Nuestro plan de desarrollo institucional, denominado Construyendo la Universidad del Futuro, se caracteriza por desarrollar una institución interdisciplinaria, innovadora, globalizada, emprendedora, digital y actualizada. Son hartos desafíos para asumir al mismo tiempo, como ustedes verán. Muchos de estos elementos están contenidos tanto en los programas de formación en tecnologías disruptivas que impulsa ExploraTec, como en los temas que abordarán los charlistas de este seminario. El que este sea un esfuerzo conjunto con UC Davis es también algo muy relevante. La Universidad del Desarrollo tiene una cultura de trabajo en base a alianzas. En este camino, compartir experiencias con socios de la categoría de UC Davis nos alegra y permite avanzar con más energía en temas que están aún en la frontera del conocimiento. Agradezco a nuestros expositores que hoy compartirán su mirada con nosotros y deseo que este sea un encuentro del que saquemos muchas enseñanzas. Muchas gracias.
Muchas gracias, rector. Y estamos trabajando en tratar de iluminar esos ángulos ciegos a través de la interdisciplina. Vamos a ver ahora, vamos a empezar con las exposiciones, pero partiendo con un saludo de la decana de diseño, pero antes que eso, invitar a los expositores que están presencialmente acá hoy a que por favor se sienten en el panel. Christina, Valeria, Fernando. Y escuchamos el video de la decana.
Muy buenos días a todos, mi nombre es Alejandra Menábar, soy decano de la Facultad de Diseño y si bien hoy no puedo estar presencialmente con ustedes porque me encuentro en Madrid siendo parte de la Bienal Iberoamericana de Diseño, no quise restarme de enviarles un saludo en el marco de este importante seminario para la Facultad de Diseño, Ingeniería y ExploraTec. En el Seminario Internacional Biodiseño y Nuevos Métodos de Manufactura se abordarán temas muy relevantes para el diseño y para la interdisciplina. Quisiera expresar mis más sinceros agradecimientos a las investigadoras Christina Cogdell y Valeria La Saponara, ambas de UC Davis, quienes nos visitan exclusivamente para compartir con ustedes toda su valiosa experiencia y sus conocimientos. El biodiseño es una materia que se posiciona en la vanguardia de la interdisciplina, fusionando conocimientos de diseño, biología, ingeniería y otras materias para abordar los desafíos contemporáneos. En este seminario exploraremos cómo esta innovadora disciplina no solo busca inspiración en la naturaleza para desarrollar soluciones, sino también cómo puede transformar los métodos de manufactura tradicionales hacia enfoques más sostenibles y eficientes. Confío en que cada uno de ustedes va a aprovechar al máximo esta tremenda oportunidad y todos los conocimientos que van a compartir con ustedes nuestras invitadas internacionales, así como también aprovechar al máximo todo el cariño y el trabajo de nuestros investigadores en Chile para que el workshop y todas las instancias que se han diseñado para esta semana sean increíbles para cada uno de ustedes. Un gran abrazo y que disfruten de esta gran experiencia y de este gran seminario.
Agradecemos la deferencia de la decano en dejar este registro y saludar a las invitadas de igual forma. Partimos con las exposiciones. Va a partir el decano de la Facultad de Ingeniería, Fernando Rojas, a quien invito al podio.
Muy buenas tardes. Saludar a nuestras invitadas y agradecer a Nicolás y a todo el equipo que ha organizado esto. Yo quiero presentar bajo una prisma particular el trabajo que hemos desarrollado, sobre todo en el ámbito académico, donde desde diseño e ingeniería hemos trabajado en desarrollar programas interdisciplinarios con un foco en tecnologías disruptivas, buscando acelerar la adopción de competencias tecnológicas y académicas en nuestros estudiantes, con esa mirada interdisciplinaria, pero que irradia no solo el diseño y la ingeniería, sino también las otras disciplinas. Como contexto, voy a hablar algo de la universidad, también de las distintas dos facultades, para desde ahí contar con más profundidad sobre este programa de formación de competencias tecnológicas de avanzada. Estamos en este campo que todos conocemos, que nos pone muy contentos. Esta sala acaba de ser remodelada y buscamos que estos espacios también facilitan el trabajo interdisciplinario. Y comenzar en primer lugar reforzando algunos de los elementos que ya mencionó el rector. Somos una universidad joven que tiene 33 años, donde la innovación, la tecnología, el emprendimiento han estado en el corazón de nuestro quehacer y donde sin duda son palancas relevantes para la interdisciplina y donde en un mundo globalizado estas temáticas tienen especial importancia, repercusión y campo, por supuesto. Hemos buscado también con esto vincular con trayectorias que cada vez hemos visto la necesidad de que sean flexibles y este programa académico que voy a mencionar tiene esos atributos. Es así también como una de las preocupaciones que nosotros siempre tenemos tiene que ver con cómo desarrollamos la siguiente, por favor. Cómo desarrollamos programas laborales de frontera y que permitan incorporar elementos no solo para las demandas laborales actuales, sino también futuras, y donde dentro de ellas, sin duda, en las materias de informática, de innovación, de gestión, de data business intelligence y otras han sido parte de los programas académicos que hemos desarrollado desde distintas facultades en la universidad. Y donde hemos agregado también la posibilidad de dobles titulaciones, algo que en Chile es poco habitual y que está buscando como universidad dar en la frontera más herramientas y oportunidades para los distintos intereses de los estudiantes, pero también oportunidades que el mercado del trabajo valora. Es en este contexto donde aparece ExploraTec y el programa de desarrollo de competencias tecnológicas más de frontera como un programa que enriquece nuestra propuesta de valor. En ese contexto, contar algo sobre las dos facultades, digamos, en el caso de ingeniería, tenemos 29 años de historia, hoy día tenemos 6 carreras con 1.700 alumnos, 2.300 egresados, en tanto Santiago como Concepción, donde el foco en la industria y el trabajo con la empresa han sido parte de los elementos donde buscamos agregar valor. Traer el aprendizaje experiencial al más alto nivel nos parece que es uno de los caminos para que los estudiantes agreguen tempranamente valor y formen aceleradamente competencias profesionales necesarias para un buen desempeño laboral. En este contexto donde el programa de ingeniería con la empresa, que hace que los estudiantes pasen 50% de su tiempo de formación de los últimos años de la carrera, un elemento muy distintivo y único en el país. Y donde también tenemos centros de investigación en data science, en sustentabilidad, o lo que hemos llamado tecnologías para la sociedad, que nos permiten vincular la docencia con la investigación y viceversa para resolver problemas más avanzados de nuestra sociedad. En el caso de nuestra facultad de diseño, donde la decana gentilmente mandó un saludo, dado que no podía estar acá. Hay una serie de menciones muy interesantes en interacción digital, en espacio y objeto, en diseño gráfico y una nueva en moda y gestión, que están buscando desarrollar con una mirada particular una serie de elementos que me parece interesante destacar. Un foco en innovación y emprendimiento, que es también parte de los sellos de la universidad, con interdisciplina, pero también con un foco muy interesante en integración de sustentabilidad y tecnología. La Facultad de Diseño ha logrado posicionarse en forma muy destacada, estando en el ranking número 2 a nivel nacional, siendo una facultad muy joven, también en lugares destacados a nivel latinoamericano e internacional, con una vinculación muy interesante de las estudiantes con realidades internacionales, que nos parece que es algo muy interesante también para abrir la mentalidad tempranamente de nuestros estudiantes, con una cultura tecnológica y una flexibilidad curricular que es muy interesante y donde se destaca hoy día un proyecto nuevo en un diseño de centro de servicios, o centro de diseño de servicios, perdón, que está desarrollando elementos muy interesantes de vinculación aplicada con la industria, que me parece también interesante que conozcan si tienen el tiempo. Tiene una cantidad interesante de alumnos, ya 1.600 egresadas, lo cual también muestra el impacto que estamos alcanzando en el país. Desde ahí nace Exploración Tecnológica, como decía el rector, hace cerca de 10 años, en un programa que, entre otras dimensiones, busca formar competencias tecnológicas avanzadas en nuestros estudiantes, donde hemos crecido también incorporando insignias como un modelo de vanguardia para que eso sea reconocido nacional e internacionalmente. Y con un enfoque fuertemente interdisciplinario sobre el cual les quiero hablar un poco más. En primer lugar, destacar lo que hemos aprendido en el tiempo, la importancia de los espacios físicos y el equipamiento a disposición de los estudiantes para un trabajo colaborativo cerca de la tecnología con las manos en la masa. Esto es algo que hemos incorporado de distintas realidades en distintas universidades del mundo y tratado de mejorar y adaptar a nuestra realidad, por cuanto el espacio físico es elemento necesario para desarrollar proyectos aplicados. Es así como nuestros laboratorios han incorporado crecientemente tecnología de punta a disposición de los estudiantes y de sus proyectos. Desde ahí es interesante el impacto que hemos generado en estudiantes. Hemos superado a los 7.000 estudiantes que han pasado por distintos cursos de estos programas con distintas materias, algunas que buscan incorporar en cursos disciplinares elementos interdisciplinarios o cursos que son de frentón interdisciplinario en su diseño con profesores de distintas aproximaciones. Algunos de los proyectos que han sido interesantes de desarrollar, que junto a investigadores de las facultades con estudiantes, se puede ver en este proyecto. Este es un proyecto desarrollado en conjunto con Siemens, que buscó en conjunto con ciertos gobiernos locales, buscar visibilizar las dinámicas de la ciudad en elementos que juntan electrónica, la mecánica y poder visualizar espacialmente las comunas de la región metropolitana y, por ejemplo, poder visibilizar la densidad poblacional, la movilidad, la contaminación y otros elementos que claramente en términos de visualización de data compleja se enriquece muchísimo cuando se agrega la visualización y la mirada interdisciplinaria. Desde ahí, lo que hemos buscado es avanzar un paso más allá en incorporación de tecnologías disruptivas para los estudiantes. Esto lo hemos hecho, por ejemplo, en conjunto con un fondo de innovación del Ministerio de Educación. Y algunas de las competencias que hemos buscado enseñar las podemos ver en estos ejemplos. Por un lado, en visualización de datos, que es algo que les mostré también en el ejemplo anterior, se ve con mucho valor esa aproximación de las dos disciplinas, donde por un lado en la manipulación de grandes volúmenes de datos, en la analítica, sin duda la ingeniería puede aportar muchísimo, pero donde también la dimensión de visualización y de diseño también vinculado a las distintas disciplinas y elementos que requiere la problemática, hay elementos muy, muy relevantes. También sostenibilidad, que sin duda es una de las temáticas que vamos a ver hoy día con mayor profundidad, donde tanto en el diseño como en la construcción de distintos dispositivos, como en el uso de materiales, hay grandes desafíos que el planeta tiene que enfrentar y somos conscientes crecientemente de su importancia. Y por último, cuando hablamos de la física y de sistemas físicos que resuelvan problemas, sin duda también en las ciencias básicas aparecen elementos muy relevantes donde, por ejemplo, la vinculación del aprendizaje con dispositivos es algo muy interesante para estudiantes vinculados a diseño de modelos, objetos en distintas disciplinas. Desde ahí, nuestro programa interdisciplinario ha incorporado distintas trayectorias. Y acá quizás detenerme un poco más en algunas de las trayectorias que hemos priorizado. En un trabajo colaborativo con la industria hemos tratado de privilegiar o priorizar ámbitos que creemos que tienen implicancias relevantes en distintas disciplinas o trayectorias laborales, donde sin duda la manufactura avanzada es algo que hoy día permea una enorme cantidad de elementos de la sociedad. A mí me gusta mucho cuando uno reflexiona con que la impresión 3D no es solo algo constructivo, sino que hay toda una revolución de los materiales detrás de ello. Algunos ejemplos siempre sugerentes acá es cuando vemos ya prototipos en el planeta de impresión de alimentos, y a partir de 3D, que son elementos muy de frontera que probablemente en el tiempo vamos a empezar a mirar con mayor frecuencia. Segundo, investigación, pero inteligencia artificial aplicada, donde el campo laboral es infinita y hoy día claramente ChatGPT nos ha llevado un paso más allá y todavía nos está abriendo un enorme ámbito de aplicaciones. Un tercero que tiene que ver con ciudades conectadas. Cuando hablamos de ciudades, claramente el Internet de las Cosas, por ejemplo, es una de las tendencias que en mi opinión todavía no explota y tiene un potencial enorme por desarrollarse y donde claramente tener más competencias de nuestros estudiantes es algo muy, muy relevante. Cuando esto le agregamos vehículos autónomos, digamos, empezamos a pensar un poquito más en grande y claramente hay temas de eficiencia energética, de contaminación, de movilidad, donde me parece muy interesante que esas problemáticas lleguen a los estudiantes y agreguemos herramientas tecnológicas para su diagnóstico y solución. Y por último, cuando hablamos de realidades extendidas, también hay un enorme potencial en múltiples disciplinas que nos parece muy interesante y algo voy a comentar más adelante, donde hemos visto que los estudiantes de la universidad en distintas carreras han mostrado interés en estas distintas dimensiones. Algunos de los cursos que hemos visto y hemos desarrollado acá con interés de estudiantes en las distintas dimensiones aparece por supuesto en metaverso o en realidad aumentada. Muchos de nosotros probablemente ya vimos la entrevista a Mark Zuckerberg, digamos, en el metaverso, que va mostrando de forma muy sugerente, digamos, el potencial que tiene esto y cómo quizás vamos a encontrarnos con nuestros propios avatars, pero representando en forma muy fidedigna nuestras interacciones emocionales y demás a partir de un contexto inmersivo como es el metaverso. O también cómo aparecen los elementos de modelado orgánico en 3 dimensiones, que también tienen un amplio campo laboral. Agregamos a eso los nuevos materiales y métodos de manufactura, lo que tiene que ver con el 5G, pero también con una mirada de agregar los MOOC como una metodología para hacer más masivo la adopción de estas tecnologías. Hemos incluso abierto a otras audiencias, esto no solo a los estudiantes de pregrado, sino a la industria o a estudiantes de colegio, la posibilidad de incorporarse a este tipo de cursos, donde creo que la distancia que hay en Chile, al menos en nuestro mundo escolar y universitario, se puede cerrar a partir de estas nuevas metodologías y donde también podemos levantar o alimentar el apetito de estudiantes para que también se motiven con estas carreras tempranamente y busquen agregar tecnología en su quehacer. Por supuesto, cuando hablamos de inteligencia artificial, los desafíos de la ética tienen que ser parte de las consideraciones que agregamos a nuestro aprendizaje y es parte de las asignaturas que hemos agregado en este tipo de programas. Quizás aquí hacer una pausa, que me parece muy interesante ver la reacción de los estudiantes de la universidad a este tipo de cursos de tecnologías más de frontera, donde si bien ingeniería es la más grande con un 24% y diseño sigue con un 11%, aparece economía y negocios con un 18%, medicina con un 16%, psicología un 10%, comunicaciones un 9%, y que te va mostrando el interés y el campo aplicado que tiene esto en distintas dimensiones del quehacer, por supuesto la arquitectura, pero también el derecho, que uno pensaría que es una carrera un poquito más alejada con un 4% de los estudiantes. Luego acá, cuando hablamos de miles de estudiantes que están motivando por ese tipo de disciplina, nos muestra que acá hay una necesidad formativa relevante y que programas interdisciplinarios que buscan generar herramientas tecnológicas a nuestros estudiantes nos parece muy, muy interesante. También, si bien algo dije al respecto, hemos buscado complementar esto con nuevas metodologías y tendencias que están apareciendo en el planeta, que podríamos hablar de credenciales, microcredenciales o también la generación de insignias, donde algunas de estas temáticas que hemos visto en inteligencia artificial, realidad virtual, manufactura digital, etcétera, se han ido traduciendo en cursos que los estudiantes pueden ir apilando para obtener después una credencial o una insignia reconocida, y empezamos a ver cómo eso después los estudiantes lo agregan a su LinkedIn y empiezan a hacer competencias reconocidas nacional e internacionalmente a partir de certificadoras como edX o Credly, que me parecen bien, bien interesantes. Para terminar, quisiera hacer una reflexión desde la vinculación que hay entre la docencia y la investigación en esto. Acá hay un continuo donde probablemente en el aprender haciendo tenemos que seguir buscando maneras en que los estudiantes pongan manos a la obra en las distintas metodologías de aprendizaje de tecnologías más disruptivas. Acá contar de algunos proyectos que estamos desarrollando nosotros en el Centro de Tecnologías para la Sociedad vinculado con materiales, donde de alguna forma incorporar temas vinculados a materiales biológicos basados en polímeros o materiales radioactivos a distintos elementos, o también cómo generamos distintos materiales capaces de reconocer la temperatura y generar interacciones con colores que permitan distintas aplicaciones en la industria. Son algunas de las aplicaciones en un ámbito muy particular de nuestra investigación, que nos plantea toda una dimensión de cómo vinculamos más los cursos, los programas académicos con la investigación y con soluciones aplicadas a la industria. Hay metodologías de la universidad que hemos hecho, desde los programas para Semana I, que son en 2-3 días, programas donde los estudiantes entran en profundidad en una problemática y generan soluciones, hasta labs interdisciplinarios que duran todo un semestre, donde se busca generar soluciones a algunas problemáticas compartidas. Desde acá es donde quiero cerrar con algunos desafíos que nos parece interesantes de enfatizar. Evidentemente, cada vez que uno se va incorporando en estos temas, el apetito por la escala es uno de los desafíos relevantes. Cómo generamos más escala en profundidad y alcance, cómo desarrollamos competencias tecnológicas más profundas y más sofisticadas en nuestros estudiantes, y es una de las preguntas que siempre nos hacemos: cómo pasamos de un apresto inicial a un desarrollo de competencias a un nivel mucho más de experto, y también cómo lo escalamos a que más facultades lo incorporen. Eso nos agrega una dimensión, un desafío vinculado a digamos, las competencias o el cambio cultural asociado. Mucho de esto dijo el rector en sus palabras iniciales, donde muchas veces uno se enamora de la disciplina. Yo tenía un jefe que decía que uno tiene que enamorarse de los problemas y no de las soluciones. Bueno, algo similar ocurre acá. No podemos enamorarnos solo de nuestra disciplina, sino que ver que los problemas complejos requieren soluciones interdisciplinarias, y eso implica cambio cultural en la forma que nos organizamos. A mí me gusta mucho repetir palabras que dijo el rector hace varios años en una entrevista cuando le preguntaban cómo imaginaba la universidad en 50 años más. Y su respuesta, bueno, frente a cómo imaginaba las facultades, decía cosas: rector, permítame, no sé si van a haber facultades en 50 años más. ¿Ya? Y creo que es algo súper relevante que repensemos, ¿ya? Porque nuestras formas organizativas generan también organizaciones, coordinaciones y descoordinaciones o distancias que creo que tenemos que que mirar, sobre todo cuando vemos que la tecnología avanza con velocidades insospechadas y cruza transversalmente los desafíos de la sociedad. Lo tercero, quisiera enfatizar acá el cómo potenciamos el trabajo de investigación en proyectos conjuntos y la vinculación entre investigación, proyectos, industria y la academia, donde el pregrado, los posgrados, la investigación y la industria también tiene desafíos de integración en proyectos más aplicados, donde el aprendizaje experiencial es una de las dimensiones que creo que tenemos que seguir incorporando. Acá hay buenos ejemplos donde, dado que, por ejemplo, dentro de nuestros proyectos tenemos un advisory board que reúne gente nacional e internacional, donde Cristina participa, también tenemos gente de la industria, y donde ellos se han abierto, digamos, a que junto con el diseño que nos han aportado de este tipo de programas académicos, los estudiantes pasen rápidamente a realizar prácticas en la industria, implementando o utilizando las tecnologías más de frontera que están aprendiendo acá, de forma tal de poder, uno, mirar el impacto que esas habilidades empiezan a generar en sus problemáticas laborales, y dos, retroalimentarnos con que el nivel de desarrollo de esas competencias esté o no teniendo el nivel necesario para ese tipo de empresas. Y empresas de telecomunicaciones, por ejemplo, Telefónica, y un gran socio nuestro está en este modelo con nosotros, que es muy, muy interesante. Y para terminar, plantear uno de los desafíos que nos parece interesante, que tiene que ver con el trabajo en red. Así como en las instituciones académicas, el desafío del trabajo interdisciplinario es una constante, también lo es en las dimensiones laborales, donde también las distintas empresas tienden a sobreespecializarse o cada una de sus áreas en la misma dimensión, y donde poder vincular más empresas, más organizaciones, el mundo escolar y otros, en un trabajo realmente interdisciplinario para resolver problemas de la sociedad, me parece que es parte de los desafíos asociados al diseño y a la implementación de estos programas académicos. Agradecer a todos quienes hacen este programa y este seminario, un seminario tan relevante, pero para terminar decir que vemos con mucho entusiasmo el interés que los estudiantes han manifestado en este tipo de herramientas tecnológicas de frontera, y donde la propia apetito de los estudiantes en programas que son abiertos a toda la universidad nos hace ser optimistas con que la interdisciplina puede crecer y la universidad puede ser un actor relevante en esto. Muchas gracias.
Muchas gracias, Fernando. Y en dotar de más contenido y bajada respecto a las facultades y a ExploraTec, después de que el rector nos enmarcó con lo que la UDD está mirando en materia de construcción de una universidad del futuro en cuanto a interdisciplina y tecnología. Es el turno de las invitadas de honor, así que vamos a partir con Christina Cogdell y su charla vinculada al biodiseño en el sentido de la circularidad y los sistemas. Adelante. Welcome, Christina.
Hello, everybody. Thank you for being here. Should I turn it down? Is that best right there? First, some thanks to University of Desarrollo, of course, to the deans, to ExploraTec, the faculty in design, and the students who have been participating throughout this whole week with us. It's really wonderful to have you here. And I'll also welcome my own students here as well. Yeah, I wanted to start by the title that I'm speaking about. I was asked to focus on industry and systems overall. And so I want to talk towards biodesign collaborations for increased circularity within systems. I've published 2 different books. I'm showing you the titles here. They are crossovers between the history and ideas between biology and architecture and design. The first book looks at the history of biological theories and architecture from the late 19th century into the 1940s to 50s. The second book, which is more recent, looks at the 21st century with ideas of complex systems, epigenetics, and synthetic biology, and how architects are envisioning using these ideas to transform their approach to design. So I show this in a timeline as a reference to Dan Grushkin's talk. When he showed a timeline of biodesign, it started in 2009, I believe, and he joked that I wouldn't like it. And that's because I think that biodesign goes back to the 19th century. So I'm one of the very first historians of biodesign and the crossovers between architecture, design, and biology from throughout the 20th century and into the 21st century. So before William Myers created the word biodesign, which we all use now, there's a long history that precedes that. So the outline of my talk today is to think about systems, right? Biological systems and circularity. And I want to do that through focusing on three main approaches. Many of these are examples from my teaching. And so I'm crossing over my own research and my books and the knowledge from that into what we do in the classroom at UC Davis to think about aspects of life cycle assessments, but also about biodesign solutions. So I'll start with just a brief introduction to life cycle analysis and the ways we think about it. I then want to move into narratives that are constructed about life cycles by my students in one of the classes I teach. And then I'll move third to the biodesign classes that I teach and give you some examples of highly innovative approaches to problem solving using bio-based materials that also have promising life cycle assessments. All right. So let's start with me doing research for my book, where I asked a very famous physicist, what is a system? Because I was interested in complex systems. But if you're thinking about design, we're also interested in systems. And his answer was surprising to me. He said, whatever you say it is. I was like, well, how convenient. But he also said that usually there's some sort of noticeable boundary that makes a system adhere into itself. So then in the context today for this topic, I want to ask you a question, or thinking about Biodesign and Industry Week, what is a manufacturing system? And here's a hypothetical answer. Some industry executive might say, it's what happens in our factory. It's how we convert materials into products for consumers. So I want to look at a life cycle system that has been outlined in the past and also how it's transforming today in terms of our understanding. So these are both diagrams of what a life cycle is, but the one on the left is an older one. I believe it's from 1992. And in both of these, what you can see is that there's a series of steps. In the one on the left, I like to refer to it as a ladder. This is an example of a linear thinking from start to finish. And you can see that what you see in the middle for the ladder is first there's raw materials acquisition, then there's manufacturing and processing, distribution and transportation comes next, use, reuse, and maintenance when the consumer has it. Then the end of life cycles, either recycling or waste management. Okay, so everything that we touch and use and live within has these steps. So to think about it, I want to move forward here for a second, and then I'll come to that one. There is a boundary that we put around this system. And so in this particular diagram, you have to not just look at the ladder on the inside, but in fact, to the idea that energy is input at each of these 7 steps. And raw materials are added at each of the 7 steps. And that at each of the 7 steps, there's also outputs, and they can be waterborne waste, airborne waste, other kinds of pollution, as well as the product itself is an output, okay? So this is the older way of conceptualizing it in linear thinking. Perhaps you've heard from cradle to grave, where it comes out of the earth and then it goes into a landfill back to the earth. Today, we're reconfiguring this into a circular because we're aiming towards circular processes within systems, but also circular processes within the economy overall. And so you see the diagram has been redrawn, and these are just, the one on the right is just you type in life cycle analysis to Google and it'll give you many options. This is one of them that I extracted. And so it's got some gaps between each of the colors. And I want you to think about that as we go through this talk today, and I'll point out other examples of life cycles. So if we go back to this and to the hypothetical answer that the industry executive gave to me when I asked this question, that manufacturing systems are what happen in our factory, you can see that the boundary around the system in terms of that answer is focused on only one of the 7 steps within the life cycle itself. So I want to point out that when you draw a narrow boundary around what you think of as your life cycle, that in fact, that's a strategic and a political move. I wanted to just say it masks the larger energy and material inputs, as well as larger waste and polluting outputs in the overall life cycle, and it hides it from consumers and from investors. So it's really important to think about, as my colleague Valeria said, how big is the radii of your life cycle? What do you encompass within the circle that you're drawing to say this is the system that I am giving you the life cycle of? So here are some ways in which we shrink life cycle boundaries and the results impact on them. If you only focus on what happens within factories, then you're actually leaving out, including perhaps ethical implications of labor in the production of raw materials. Or you're also removing the responsibility for the end of life phase from the manufacturer. It's throwing it onto the consumers or onto someone else to have to deal with that problem. So this is another implication of how big you draw your circle, what you look at. It affects how you actually design and think and how it functions within society. Here is another way in which you can shrink life cycle boundaries. Think about this as the original drawing, zoom in, down, if you will, to make it smaller. And let's look at the gaps that are between each of the steps. So if you look at between raw materials and, say, preliminary production, well, what is actually, in fact, in the middle of those things? Well, there has to be transportation. The raw materials have to move into the factory from where they come out of the earth. So I added an 18-wheeler truck to the outside of it, if you see an enlarged boundary. Similarly, to extract the raw materials, you need bulldozers and other kinds of high-tech equipment. To power the factories, I'm putting in green energy systems of solar panels and wind. But these, again, are external to the life cycle. They're things that are missing or they're beyond it, per se. And you can go around and continue to trace this. And even in the recycling part, I'm showing you basically a kiln that melts down metal. Incredible amounts of heat go into the process. So that's huge amounts of added energy going in. So the point that I'm making here is that each of the tools that is beyond the boundary of just the strict circular LCA, it has its own life cycle, right? We could just start with that and actually do a life cycle. So if you think along those lines, that each life cycle is like a system, these systems all interconnect, okay? If you zoom and expand outwards. So how big is the radius of your thinking is part of the question here. And I think that the choice of tools that we use in every move that we make as we design and manufacture and use has an impact on the broader environment and how quickly we bring about change. So here are some of the takeaways that I think are from this kind of short introduction to life cycles. Systems are not closed, but open. We can think of a life cycle, it looks kind of like a closed system, especially if you go circularly. It's not at all. Life cycle assessments try to expose the embedded energy, the embedded raw materials, and the waste and pollution outputs of it's an open system, okay? Where one bounds a system is strategic and political. Because systems interconnect, the tools that we choose to improve a life cycle in one system can cause ripples across into other systems. So my best tips to all of you for transparent thinking and for transparent LCAs: draw your boundaries widely and choose your tools very wisely. To me, the bottom line for improving environmental sustainability is improving the life cycles of everything that we touch and use. All right, so I want to move to some examples of how I integrate life cycles into my teaching. There's a class that I teach called Energy, Materials, and Design Across Time. And in the main project that I have students do comes in teams of 3. And I assign each team to pick a current material or a current product that exists in the market today and do some investigative journalism I want them to try to see what the life cycle is. So I'm not asking them to mathematically calculate the exact amount of CO2 or energy, because we don't have the skills to do that in this introductory class. But I get them to think about the story. Where did it come out of the ground? What were the materials that first were used? What is added at every step? What energy is used, and what are the waste and pollutions, as we move to thinking about what happens at the end of its life. So all of these projects, I've been doing this now for like 15 years, and the website designlifecycle.com has existed, I think, since 2015, maybe. All the students upload their projects onto this website. So it's a public resource where one person writes about the raw materials, one person writes about the energy, the other one writes about pollution, and then together they design a poster that tells the story of the life cycle of the material or the product that they chose. So the short version of looking at this without reading all the papers is to go to the website, type in what you're looking for, and then if we have it as a topic that's been researched, you'll see a poster. So not all of my students are design students. In fact, many of them are engineering students, and I love having the engineers in the class. They've picked a variety of topics, and basically it's in any of these categories. They can pick anything that fits. Architecture, digital and electronics, fashion and textiles, furniture, graphics, lighting, products, and then the nebulous other category. And so I encourage you to explore these. I just picked 3 that show you different things. I've always loved this one of the life cycle of a brick for architecture, partly because the poster is hand drawn. My students don't have to be designers, they don't have to have, access to InDesign and know how to do it, but they can still make beautiful posters and think through the life cycle of something. So in this case, it's a team of only 2 students. One of them studied the energy, the other one studied the wastes, in terms of they listed them by their carbon, their elements, basically, their chemical elements. And then if you look in the middle, they're just moving through the phase from the raw clay is extracted from the lithosphere, it's transported, it's mixed, smashed, sifted, and cleaned, kneaded with water, shaped and dried, furnace, fired, and then it moves out of the factory. It's packed, it's stored, it's loaded, distributed, all the way through 100 years later, demolition, downcycled into concrete. So 2 other examples that are a lot more high-tech than the brick and a lot more, InDesign, current technology design posters. A team looked at the one-wheel XR, and I love their point without reading any of the fine print. Invented for sustainability, but at what cost? And they have this summary under energy. Despite the one-wheel XR board being an invention intended to be sustainable, a lot of energy is used to manufacture, maintain, and recycle its parts. So a lot of these life cycles are depressing. There's only a few that give you hope. So here's to biodesign transforming that to the future when we have better life cycles for our materials and our products. The one on the right, it was a team of 3 engineers that paired up together to study the life cycle of basically the transistors within chips. So silicon wafer MOSFETs. And you can look at their poster, but the graphic on the top right shows you the most obvious takeaway, which is the energy, that tall column of yellow that's used in the production phase kind of outpaces everything else and the impact of it. When you think about the fact that transistors are used in chips that are used in almost basically every digital thing we have in the world, and that we're moving more and more towards that ways, it begins to make you think about the energy that goes into our digital technologies and the finitude of the raw materials that are being extracted from the earth to also go into these technologies. So these are 2 examples from engineering. So I think that this approach is useful across the board to think about different types of designers and how we can understand the things we use today. So I wrote a paper that was published a few years ago in Sustainable Design and Manufacturing from a conference that took place in Europe. And it was about my students, some of whom have been engineers and bioscientists and designers. Many of them take my class on energy, materials, and design, where they learn how to do life cycles. And it's a really depressing class because we're covering the history from like the Stone Age into the present of energy, materials, and design. And we're looking at population growth, pollution growth, global warming as the big context. Turns out all the students used to want to take like modern design. Well, from the perspective of energy and materials and pollution, when we discovered fossil fuels and mechanical production, everything starts to decline in terms of environment and aspects of the outcomes of life cycles. So my class is depressing. And I tell them that if they're really depressed from this, and of course they're already depressed from the world situation when they come into my class, let's do something constructive after the fact. So my recommendation is take the biodesign class and let's start to do something about this. So this paper was an attempt to describe what we do within the biodesign class. And I just wanted to highlight a short thing about it. In the abstract, here's the summary of what I argue. It then discusses and argues that the process of sustainable biodesign innovation is enhanced by interdisciplinary collaboration between designers, engineers, and bioscientists. And owing to their complementary theoretical knowledge, technical training, approaches, foci, and skills, this process can actually be utilized in industry for sustainable biodesign innovation. So what I want to argue now and give you examples of is what we do in our biodesign classroom is kind of a rapid prototyping innovation experience. We have 10 weeks once they start in teams to solve a problem using bio-based materials or bio-based processes. And they have to prototype it, do scientific experiments, put together a website, have a pitch, and then because the class allows one team to go to New York to participate in the Biodesign Challenge competition, which Udede also participates in and won a prize this year. It really motivates them, somewhat like a startup experience, to work fast, to work hard, to rapidly innovate and come up with good solutions. What I'm saying is that if you do that in industry, if industry was to put together engineers, bioscientists, and designers in the same room and give them what might be called a flash research assignment, you can get some really interesting results out of this process of collaboration. All right, so I just want to show you 3 examples really quickly. So this is a first project. It was a team called Myco Masonry. They wanted to replace styrofoam ICF blocks, insulated concrete forms that are used for construction. So they proposed and designed a block made out of mycelium, which is a great insulating material and is being already used in industry for insulation for architecture. So just to show you something about them, Gabriel is a designer, Carolyn's biochemistry and molecular biology, Derek was an economics major. All of these use concrete, they still use rebar. This team, Imagine, will soon have bioconcrete that will be better, and so that would be green too. And the goal is not just to replace one green material for something that's bad, but to actually improve the life cycle of the whole system, okay? So it's very exciting. That was their idea in 2022. This year, the first panels that are being manufactured to actually build an apartment complex in Oakland, California, are being created at Autodesk by David Benjamin in the living, doing the mycelium design and production on the inside, with Chrysler and Associates doing the exterior cladding. Mycelium, even like styrofoam, needs still a material on the inside or the outside. So looking at the recent example of what Chrysler and Associates did, the facade at SF MoMA, here is a process from their website that shows them in creating the panels that went on the outside. They say it's made from fiber reinforced polymer combined with an exposed aggregate polymer concrete finish. So my question is for my students would be, what is the life cycle analysis of fiber reinforced polymer with aggregate polymer concrete finish? Well, then you say, well, what is that? These words, when you just say it's a polymer, you're like, what is it? What's it made of? It's often hard to figure this out if they don't actually tell you. So it appears to be fiberglass with polyester resin, which is pretty toxic. And so here we have a really green material being bounded by a really toxic material to protect the life and have it look cool and become the first building ever with mycelium in it. So this just points to the quandary that we're at today, okay? And what it means to me is that we need non-toxic bio-based binders ASAP, because we're stuck kind of with the old and the new until we can come up with that problem that allows us to build better and create better materials overall. The next example, really quickly, the team that went this year to New York is called C Nails, and they wanted to create a replacement for acrylic nails within the nail industry. Sariko is mechanical engineering and design double major. We had 2 other designers, and we had a bioscience student on the team. So this is one of their slides. They said, you know, the nail industry, we know it's toxic. If you've ever been to get a pedicure or a manicure, lots of people use this. Unethically sourced mica is in the glitter that's used, as well as the chemicals, dibutyl phthalate, formaldehyde, toluene, and methacrylates are used in the process of the nails themselves. So they're like, what can we do to make this better? Yeah, and they don't biodegrade. Well, turns out in the California fishing industry, there's a lot of available waste, okay? Only 25% of the catch is used and consumed. 75% is wasted or dumped. So we ran into a person nearby who's starting a fish leather company named Aquaborn. So he's getting the waste from California fisheries to make fish leather nearby. And he said, I'd love to work with you. Would you like some fish scales? Would you like any parts of the fish? And we're like, sure. So we took the waste from that, and they ended up developing an entire system where they used the fish scale as the actual nail, as the base. They cooked down fish air bladders just with a boiling water method to create a glue that was strong enough to hold the fish scale onto your hand. They dyed the fish scale in beet waste, which was just beet and water. They centrifuged the fish waste from tanning the liquid that caught the iridescent guanine that was in the skins from the fish leather process. And we just centrifuged it and got the glitter out. And so then they put the glitter onto the top of the shell with a little bit of shellac. So shellac comes from the Far East. And so all of this is local waste. I love that 4 out of 5 of their materials are sourced like within 30 to 40 miles within our state, okay? And all they did, by the way, was heat it up, centrifuge it, dehydrate it. That's it. No added chemicals, except for the shellac takes a little bit of isopropyl alcohol, 90%. So here's their life cycle. It's unconventionally drawn, but it's to highlight how local everything is. When things are local and it's all waste materials and it's all natural materials, like to me, this is almost a near perfect life cycle. Unfortunately, yeah, they show a plane or maybe it's a boat that brings the shellac from East Asia. But if you were to have that in California, it would be almost nothing done. And it's an absolutely beautiful biodegradable replacement to acrylic nails. My last example is Sea Glass. This was the team that competed the year before. They started out trying to solve the problem of medical and laboratory waste, all the plastic we throw away. They ended up looking to a company in San Diego, scientists who are creating algae polyurethane. They're making it really biodegradable, truly biodegradable algae bioplastic. The team consisted of cognitive science, Victoria, Sloka Suresh, biotechnology, raise your hand, Sloka. She's here as a senior now. And Amabel Gale from computer science and design. Sorry, if I go back one. Here is the life cycle that I'll be done in 2 seconds, that they put forward. Basically, they wanted to solve 2 problems in one. They knew that algae can remediate wastewater. So they said, we have a problem with wastewater, nitrogen, phosphorus, et cetera. So let's grow algae at our wastewater plants. But instead of algae blooms, we're actually going to harvest it and then make the algae-based polyurethane from it. From the algae-based polyurethane, instead of making medical waste, which was medical vials, plastic vials, it's too expensive at this point. So they wanted to make something that would sell, that would be high-end, just to get the company started. So they chose designer glasses. And then when you're done with your glasses, you can just compost them. But it's actually a really durable plastic. So it's a really wonderful life cycle that solves 2 problems. Yes, it omits certain parts of things that would have to be done, but it's really interesting because this shows 2 systems interconnecting, wastewater and product design. So all of these are solutions that move in a really positive way towards improved life cycle assessments. I don't have time to read through this, but I'll just wrap up by making the point that I think by having this experience in the classroom, that industry should use this as a model for how you could actually bring about rapid change from, if there's already an industrial producer that's willing to take the risk and look to these new materials, they have more of the means to start to do these experiments and bring them to market. Thank you so much.
Muchas gracias, Cristina. Muy interesante cómo se materializa en la clase de biodiseño la convivencia de diseñadores e ingenieros atrás de encargos comunes, que es algo que nosotros estamos intentando y creo que hemos encontrado una cierta manera de empezar a desarrollarlo acá en la Universidad del Desarrollo también. Así que ahora vamos a invitar a Valeria La Saponara del Departamento de Ingeniería Mecánica y Aeroespacial de la Universidad de California en Davis para que dé la última charla de la tarde para que luego rematemos con una ronda de preguntas.
Oh, here we go. Okay, good afternoon. Thank you for invitation to Universidad del Desarrollo and to ExploraTec for being here. Valeria La Saponara. I'm going to breeze through these slides. I want to show you just discuss the images that you're looking at. Okay, old style. This looks like that coral, but it's a live mushroom. These are the students, mostly undergraduate students that I work with to build. Mostly undergraduate students that I've been working with for the mycelium bamboo biodegradable winter beam blade. And this is actually the project that started it all, bike helmets. So the project I've been working with, it's based on mushrooms, and actually it's a type of new material that has a lot of manufacturing possibilities. Excellent teaching topic for a lot of students and myself, and it's very multidisciplinary because we have an incredible array of possibilities to have interdisciplinary research in biology, biodesign, agriculture, bioremediation, and medicine, and obviously, of course, engineering. So it all started with my startup. I have a white child with a son, and I have, something. Oh, sorry. No, this is, okay, this is good. Okay. Okay. I have a white son and a black daughter. And because Davis is a city that has a lot of bikes and bikers, one of the issues with my child's safety is that bike helmets don't fit African-American hair because it's basically thicker. And there are a lot of different hairstyles. And you're seeing my daughter's photo here in the center in one of her hairstyles. You cannot fit her in a bike helmet. So there is an issue about safety. And a friend of mine who was also a mother and myself decided to do a startup to design bike helmets that are safer for children that have different hairstyles and different head sizes. Hard to fit children. So we started with polyurethane because we are a startup of two, no money. And so basically we started with something that was available in the shops, mix and pour polyurethane, and we started doing shells that would be eventually replacing the polystyrene shell inside the bike helmets. And my idea was, we have the cork industry, we are in wine country, California, lot of cork, put them in there. And so you're seeing here a very improvised impact tester that we had in our little co-op of startups. And then suddenly what happened is the foam stopped working the way it was supposed to work. It started foaming too much, and I have all these weird shapes coming, and obviously you don't want that in your helmet because it would be completely off your head. And so this was also very toxic material, it's polyurethane. And so I started looking into alternatives. And the alternative that I found is this fungal mycelium that is grow it yourself material. It's a bag that arrives with the mushroom in the bag with the agricultural biomass. And I'll go first to tell you what is mycelium. Mycelium, it's in your fridge if you don't eat your food fast enough. So this is my box of berries. And basically, if you let it grow and not eat it, then you have this white substance in the berries box. Or I got these potato bags that have all this white substance that is there. It's basically the roots of fungi, roots of mushrooms. And this one did all kind of really looks like a fan. But in reality, when you find it in nature, in a forest, it's the root system of mushrooms. And so that's apparently, well, that's my photo of apparently a super toxic, poisonous mushroom that I did not pick up. But it's basically in Mother Nature, it's available. It's a polymer, natural polymer. So I started doing all kinds of different things. Going back to this, this is basically, this is in my house, this is in my garden. So when you do a startup and you have no money, you use your laundry room, your kitchen. It's very normal. And I was trying to incorporate cork into this material because I needed to do something different and I could not get it to work at all. It kept molding. So there is all this nasty mold and eventually we shut down because I couldn't figure out what was the problem. I'm not a biologist by training and I just never let it go. So we stopped in December 2019, then we got COVID. And fall 2020, I'm like, I want to figure out what went wrong. And I also wanted to use local agricultural waste to grow the mushrooms. And so a colleague of mine gave me a bunch of almonds. We have so many almonds in California. You have a lot of walnut shells and walnuts here in Chile, probably almond as well. So local agricultural waste. And I started experimenting. And then one of the things that really changed everything was the fact that I found out that you can use an Instant Pot to sterilize. You don't need an autoclave, you don't need a laboratory, you do this in your kitchen. This was an Instant Pot on sale for basically Christmas sale, holidays sale on Amazon, $60 US. And I started doing everything on an Instant Pot. And this is actually the news that's propagated, and it's now at ExploraTec. That's what they're using for sterility. I did all kinds of stuff on my own to begin with. And then finally, sometime in spring 2021, I got contacted by a student, a Master of Fine Arts student in design. Her name is Eldi Lazaro. She used to work with Professor Katia Vega from the Department of Design. And LD on her own had done this project of building prototype boards for electronics out of mycelium using the commercial bags. And she wanted to know how strong are these microboards. So we started collaborating together because they did not have access to a machine that could do this test. So they are as strong as crackers, basically, very easy to break, completely useless in terms of material properties, and they will never be able to compete with the plastic industry unless the material properties become very much better. So this is a bending test, and they really broke like crackers. So from that, we decided, okay, we need to keep working on this. And I also ended up reading a lot about mycelium and finding out that the mushrooms can clean up the environment from contaminants. So DDT, PCB, arsenic, heavy metals, other heavy metals, antibiotics, all kinds of things could be, according to the papers, remediated by mushroom. So my problem is I have no biology experience, never done biology in high school, college. In Italy, we don't study biology when you do engineering. But fortunately, I was contacted by Vanessa Salandes, who wanted to do a volunteering job in my lab, and she happens to have a biology degree. So I was like, yes, come on board. And then the question is, okay, what do we experiment with? What is the first contaminant? I mean, you know, you have so many of them. With what do you start with? And so I started working with Amir Taha and Nitin Nitin in food science and technology. Amir Taha has found out that there are so many antibiotics. It's basically the same level of antibiotics in farm seafood and in fresh seafood, wild seafood. So you have these antibiotics, you need to remove them from the water supply because they're making all us sick. It looks like weird, but I'll show you next. So we were able to write a proposal. We got some seed funds. And the important thing I wanted to point out is most of this work was done voluntarily by a lot of undergraduate students and high school students, plus the biologist. And this was the image that we used for the proposal. We're using agricultural waste. I have a story about this as well. So why antibiotics? You're taking antibiotics to be safer and healthier. The problem is that the bacteria are also taking antibiotics and they're becoming resistant to antibiotics. So there is this global health emergency that is a lot more serious than COVID and malaria and you name it. It's basically the issue that you cannot cure diseases with antibiotics in many countries. If you're trying to use penicillin against E. coli in Mexico, it's resistant. E. coli is resistant to penicillin in Mexico. Chile, we're still doing pretty well. We don't have information on a lot of different countries, especially in the global south. We don't know how bad the resistance is. And so if you reduce the amount of antibiotics in water, then the bacteria don't have the time to learn resistance. So we also looked at structures because we wanted to find out better structures to be putting, prototyping boards on. And I started working with a number of undergraduate students. Santiago Mejia on the left is a mechanical and aerospace engineering student, and so is Alex Weinstein. We did bending test, impact test. We actually started with plywood because we wanted to make these beams stronger, not like crackers. That's Alex. Kyle is also an undergraduate student, and that's Vanessa. And so eventually, with a combination of local biomass and our own mycelium, we were able to create these bags. For anybody who works with mycelium, having a white, fully colonized bag is a really great thing to have. And so we were very happy about it. When we did the test on antibiotics, we were able to reduce the concentration in 3 days, but not for all of them. So we've been trying to get more results to publish. And these are all antibiotics used in human medicine and veterinary medicine. And we're all taking them when we have an infection, we need to go to the doctor. And this is why when you go and you do one brown antibiotic, it might not work. You have to try more. So we're also looking at other contaminants. Use machine oil, brake fluid. I get very impatient sometimes, so I have a bag of mycelium and I just open the bag and say, okay, eat up. So I actually put these materials. This one is my bag of mycelium. I gave it some used oil, used machine oil from my neighborhood. And basically it's eating up the oil. It's a chemical material, so it will break down and will basically digest the oil. I wouldn't eat the mushrooms, but it's breaking down the toxins. And you can actually track these chemically. And the next thing that we have been working with is proposing bioremediation of herbicides that are used everywhere, Roundup type of materials, very toxic. We want to see if we can use a type of mushroom that will actually reduce it from the soil and water. And I don't know if you know, Roundup is a carcinogen. So we're using it, it's in our food. So the other thing was, okay, plywood is really toxic because it has a glue. I want to try to do aerospace engineering structure. I am an aerospace engineer, so I cannot do wings of airplanes. I can do wind turbine blades. And that's basically where we went. So wind turbine blades are sustainable in terms of wind energy, but when you're done, they end up in the landfill because basically this is the size of a tractor over here. And these are all wind turbine blades full of fiberglass and additives and materials that cannot be degraded. So they're all covered by soil. They're covered by soil. That means that eventually they finish in your food and your water. So I thought, well, can I use plywood? How about we use bamboo? So I watched this documentary that shows this beautiful structure in Bali made by an architectural firm. They use local arts and crafts people. And basically, we decided to propose to our College of Engineering to do a project using bamboo and mycelium. This one looks like lamb chops. It's not. This is the first sample I made to do the pitch to my college to basically say, look, I can bind mycelium to bamboo, give us more money, and we will build you a wind turbine blade. We will make it, we will build it. So we did. Before I show you the movie, this is one of the many, many pictures of the process. We basically have a similar high carbon footprint of getting bamboo from China. We don't grow bamboo in the United States enough to have a variability of products. These are the mycelium samples, and we got interviewed. We have a movie over here on YouTube and an article. And this is the first time that we actually showcased, actually second time that we showcased our wind turbine blade. Nicholas is a mechanical engineering student. Dominic is double major, undergraduate student, mechanical and aerospace. Shuao was an undergraduate student. I recruited in my class, then he became a research engineer, and now is a PhD student in a different university. Ando is the person who did all the aerodynamics research, because this is a multidisciplinary engineering project. Oops, sorry. I need to go back here. So I have collaborators from civil engineering and mechanical and aerospace engineering, Michele Barbato and Camille Badria. Could you show me the movie? So this is Shuao, who's actually running the blade. So this is the blade, all built. This is my lab, and it's just going to spin it. The turbine was actually bought out of Amazon for $270 US, and we replaced one of the blades. And this is one of the first time that basically we got it on camera. And then we stopped. So we covered it with polyester fabric that's from design. Actually, they have a lot of cutouts in the fashion design lab. And so we just use that to provide an aerodynamic structure. So we moved from the previous one, which is 400 watts. We never tested this. This is 60 centimeters, to give you an idea of the size. We built the 1.1 kilowatt, which is 1.1 meters. And we are going to test it on a dynamometer. We need to see first if it breaks. If it doesn't break, we build the next two, and then we actually set it up outside this building on campus. These are my undergraduate students. Zayad is a civil and mechanical engineer, civil and aerospace engineer. Nicolas is mechanical, and Shivan is a chemical engineer student, undergraduates. So one of the things is we're actually a little bit behind with schedule, because I've been working mostly with all undergraduate students since May, and they have exams, and basically sometimes you have to adjust their schedule to yours. But we're ready to test at the end of basically December of this year. So I also have another project, and this is where the second collaboration with design happened. This is a project funded by Sandia National Lab. The idea was to replace the tiles of sidewalks with material that is based on mycelium for replacing of concrete in the construction industry. And so I'm working again with Michele Barbato from civil engineering, and the Sandia principal investigator is Carlos Quiroz-Sarita. And it just happened that I learned about Alejandra's work and Christina Cogdell, who's their Master of Fine Arts advisor. So when Alejandra was a graduate student, she started working on incorporating textile waste in the recipe for mycelium. And you have seen this activity yesterday in the workshop. You will see her speak on Friday about this project. And so this is her in the lab making some of the samples that we're going to test in compression. They are cubes. We tested in compression on this machine. And what we found out is that the properties depend on the type of mushroom you use, how much waste you put, and also the content of textile waste overall. So you need both carbon and nitrogen. And so one of the interesting things that happened to me is that I was able to incorporate my culture in terms of food into the recipe for mushrooms. I come from Italy. We eat fava beans, las habas, a lot. And I know that fava beans is very good for soil. So I was wondering, hey, does the mushroom like the fava beans? Yes, it does. So what happened is I ate the fava beans and I gave all the pods in the mushroom to the mushroom. So the mushroom grew up very well and then it stopped growing because it's not just nitrogen that you need, it's also carbon. So this is from my garden. It's the fava bean stalks. They look like bamboo actually. And I planted a quarter of an acre of fava beans in the land, research land on university campus. It took me 6 hours to plant by hand because I wanted to try the hand method, no tractor. And these are my students who came to help me harvest. After 20 hours of harvesting overall, we're like, okay, enough fava beans, we are done. And we actually had to waste a lot of fava beans because there were already 3 weekends that we've been harvesting. So if I ever choose to be a farmer, I can tell you I have a very good yield by hand. So this is me harvesting. This is the fava beans that I cooked in this dish. In Italy, we use a lot of bacon. We don't have pancetta, but we have bacon and cebollas. And that's actually the biomass is used to create this sample of mycelium. So I never knew anything about mycelium before Star Trek Discovery 2017. That's where I learned that mycelium is a network, and in Star Trek, it permeates everything in the universe. And there is a character in Star Trek called Paul Stamets. I didn't know that he actually is a real person. And so this is how I also connected my love of sci-fi, science fiction, with mycology. And I wanted to show you this again to show you how many disciplines are completely connected into this new material. This material has a lot of potential for manufacturing. There are challenges. It's still very labor intensive, but we're hoping that with multidisciplinary research and teams from different institutions who are interested, we would be able to make a very big impact in industry. And I would like to conclude thanking again the Universidad del Desarrollo and ExploraTec for inviting me. My startup co-founder, I was the only engineer, she's the business person. People that work with me, including Christina Cogdell, without her organizing this workshop together with ExploraTec, I would not be here. Funding sources, my family has put up with basically my kitchen. Every so often I'm doing experiments. I say, okay, get out of my kitchen. I need to do more experiments. And this is my office at home. Boxes of mycelium samples. I also have myceliums in my plant because I'm doing testing with the plants. And this concludes my talk. Thank you.
Muchas gracias de nuevo, Valeria, por esa charla, cómo conecta con la ingeniería y al punto de poder incluso manufacturar lo que pudiste mostrar a partir de materiales y el biodiseño. Muy interesante cómo se conectan las disciplinas en estas imágenes y relatos. Estamos bien con la agenda, tenemos un espacio ahora para, si quieren formular preguntas a los charlistas, incluido el decano. Así que primero ofrezco a alguien o personas en el público que quieran formular alguna pregunta. Ahí hay uno. Juan Pablo.
Hello. Hi. Oh. Hi.
I learned a lot about mycelium today. Now I only knew that you use it to explore the universe. That's the whole idea about that. But I know that have you a very useful building material. My question is for all of you.
How well how expensive do helium in enough quantity to
How costly it will be to produce enough mycelium? Actual example, to actually building blocks or metal elements have competitive to actually replace more common materials.
I can try to answer that question just from the companies that I've been to that are actually growing it. So I've visited Mogu in Italy, and they are growing mycelium for acoustic panels and also for flooring, where they compress it and combine it with resin for floors. They have fairly large warehouse spaces, and they simply stack shelves, 1, 2, 3, 4, 5. So they're growing it floor to ceiling on different shelves. It takes about between 1 week to 2 weeks to grow, the mycelium the first time. So you might think that nature's time scale doesn't match industrial time scale. But if you have enough storage space and growing space with controlled environments, you can be growing the time gets built in as long as you have the space to be growing it. So once you've grown it, as long as you can be growing enough, I think that the time frame kind of disappears once you're in production. So Ecovative in New York is another much larger company than Mogu, and they have been growing at quite a large scale for a while. So I think this is an industry that's just beginning, and I think as more people find it profitable, there will be more space and facilities devoted to growing it. I do believe that it is a viable material, probably within 5 to 10 years on a much larger scale.
I also want to add that right now labor is costly because you have to do a lot of the pieces by hand. But for example, we learned that there is a project to do 3D printing of mycelium that is here at UDD. And so there are a lot of manufacturing possibilities that are open to people who are innovators, and they just have to think about, how to do this in a mass scale production. We are competing with very cheap but very toxic materials. So the industry will have a lot of resistance to change because it's way cheaper for them to go that way. On the other hand, this material is excellent for the carbon footprint because it has very low carbon footprint, and mycelium itself stores carbon footprint. So when you compost it, it brings it back to earth. And I think there might be some possibilities considering carbon footprint, not bonuses, but basically advantages for companies that want to get the tax credit of a polluting glass. They could also move in this space. Thank you.
Muchas gracias. No sé si hay más preguntas. Ahí Andrés Cepeda, Gabriel. Sí, Andrés, si te puedes parar porque el alcance del micrófono está sujeto a que...
¿Sí? ¿Se escucha?
Sí.
I have a question for Valeria. What kind of manufacture techniques are compatible with mycelium? Because I know that molding techniques are used, but have you tried in your lab another kind of techniques of manufacturing systems? I don't know.
So for manufacturing to make the winter beam blades, we had to cut with a scroll saw afterwards. And one thing that we realized is that I used the grain to grow the mycelium, but it has to be actually cut down. It has to be more homogeneous than it is. So it takes a while. It takes, again, a bit of time to figure out how you cut the material. We have been using, I like using, and I like reusing my plastic containers. I buy the food and I use the container to grow the material in. So I ended up actually growing the mushroom in the containers of the mushroom I bought at the supermarket, but obviously that's not very, scalable. But what I tried as much as possible is to look at the cheapest possible way to do this, because I think this is an opportunity for people to get into this area with very, very low cost, Instant Pot, $60. The mushroom itself, the cultures I started with are $15 US, but then you can make 6 different jars and you can just keep propagating. So there is definitely an economy of scale. The only thing that I see right now as a technology bottleneck is the cost of labor. This has to be more automatic. And so this is why I was excited to talk about Lucas Kaufman at UDD, who's working with the ExploraTec team to look into 3D printing of this material, because it would be one way to accelerate the entry into market.
Okay, thank you.
Thank you.
Muchas gracias. ¿Alguien más tiene una consulta? Ahí, Paula. Si te puedes parar, Paula, porque se corta a veces la señal cuando estás sentada.
Okay. Hi. Well, first of all, thank you very much for the talk. Very inspiring. I was thinking about biomaterials being, very cool, very hip. At least that's how they are felt here in Chile. They are not so known, maybe. They are a bit elite. And because of that, they are a bit expensive. Partly the reason why people and industries especially end up preferring plastic and more conventional materials. I know that it's changing with younger generations because they prefer better, healthier life cycles and everything. And they are much more interested in this. And while I know that you teach at universities for adults, even though you mentioned high school students every now and then, I was wondering if you have ever considered designing sort of a legislation in order to integrate this discipline for schools or even preschools, like going more into the political, considering that you work at the University of California and you have that access to the state. I don't know.
I'll just jump in a little bit. This year at the Biodesign Challenge in New York, there was a team of high school students who actually took that on as their project, and they wanted to introduce it to elementary students because they feel like these should be the materials that the youngest generation is growing up thinking of and knowing how to work with. So they designed a curriculum that would begin to do that. So I think it's a great point. I think you're not the only person thinking about this. We do have connections in terms of physical closeness to Sacramento and to policymakers. There are various labs and departments at UC Davis who have more or less impact on policy because of their focus through their research and their activism with companies and with lobbying. So I actually think that's a very important part of this bigger picture. I'll give an example of the algae polyurethane company that I described that was used for making the glasses. They need a policy change because the description of biodegradable is a very technical language. And in fact, it prevents them from using that word on their box, their packaging to sell their product. So its biggest feature can't actually be listed because of how policy defines that term. So that's just a very small example of the really important need to shift policy and language as well as education.
I have the experience of I've worked with 4 high school students, and they all actually the 2 who graduated and went into engineering, but one of them is proposing to use mycelium for coastal erosion project, and she's going to trying to present it. And I think the more exposure to of this material or this information to high school students eventually is going to propagate forward. I haven't worked with middle school students aside from my own kids because basically there is some sterility aspect that needs to be satisfied. But I think that, this entire project started when we did, in my lab, we did a test on a bike helmet being hit by this hammer. And that was actually for middle school students of these parent groups. And so it really all started with doing this test, and my friends say, hey, is there a bike helmet that I can use for my daughter? And if you think about it, it started as a children project. all together. And so I'm hoping that we can go back and actually circle back and get this incorporated in school curricula that are for younger kids.
Muchas gracias, Fernando Rojas.
Thanks, Christina and Valeria, for the wonderful presentations. Two questions for both of you related with the enablers and the difficulties of this interdisciplinary work. What were the main, or what do you think are the main obstacles for this interdisciplinary work, and the two or the main enablers that can speed up this collaboration?
I have just an observation that I have gained from visiting UDD. I highly respect and I'm grateful to my organization, UC Davis, of course, but it is a typical traditional university with different silos. Departments are isolated, labs and equipment are isolated. Money is isolated department by department. And so when I teach biodesign, when students come up with an idea like using sea urchins to make a 3D printer filament, we have the hardest time finding the grinder because we have to figure out who in geology has the grinder. We have to get access to their lab. They don't want to train undergraduate students how to use the equipment. They're graduate students using the equipment. So I have been a fan of UDD from the first time I walked in here to the labs downstairs. There's chemistry, there's mechanical, the engineering, the materials lab, the maker spaces. You have it within a radius of a 5-minute or 2-minute walk. And if there's access to actually do the tests and make the materials and collaborate in the lab space with the right tools, I actually think UDD is better set for fast biodesign innovation than UC Davis is at this point, because I can't get quick access to tools.
So I would say some of the people that probably are blocking some of these ideas are people from academia, because when you try to write a research paper, they actually, basically reject it multiple times. And you just have to say, okay, I'm just continuing. Only the antibiotics paper, we have been basically trying to publish it for the last 2 years, has been rejected 7 times. And it's a little hard, but you're like, okay, I'm just going to continue working. And so I think one of the enablers is you must be passionate about what you like. And that will keep your, office full of boxes of your projects, and you just keep talking with people. And, across disciplinary disciplines, this has been really nice. It's been nice to go back in person after COVID, because then you can basically bore my friend to death when I'm going out to dinner and talking about, oh, mycelium here, mycelium there. And, just a personal connection on making a pitch to a person, but very informal. I think that's really good. And working with students of different disciplines, that's critical, because I think a lot of our students, when they go through a more formal academic program, they think inside the box, and they think that maybe if I go outside the box, I'm not going to be valued. And they need to believe that there is value to their ability to think across disciplines.
Muchas gracias. ¿Más preguntas del público?
I have a question from chat. In any on every bottleneck you're said, like in this conversation, do you think Chile has an advantage that we could use as students?
I think Chile has a fantastic advantage. So in life cycle thinking, generally the higher tech you get and the smaller scale you get, going to nanoscales, it takes higher amount of energies to produce the materials and the technologies to make the advanced technologies possible. So I'm a firm believer in, of course, using them, but I also think that being limited in your technologies and having knowledge of the history of lower technologies, that in fact, you have constraints that perhaps people who have much more money and much more access to higher technologies, the constraints make for good design. And we need rapid design with less energy and less processed materials involved. So in fact, I think it's an advantage in some ways not to have some aspects to high technologies, because the constraints make you think more creatively to make do with what you have available. That may not resonate with you, because I know there's often an admiration of the highest technologies in the richest countries, but I really truly believe that it's within constraints that we need to work rapidly.
Thank you very much.
I can also add another thing. First of all, I think you have access to an agricultural bounty that is really important because we're looking at using this biomass to basically create all these different materials, and it's just near here. And the fact that you have this very interdisciplinary program between design and engineering is really creating students that are used to think in a very outside the box. So I think that's a really big advantage.
So I have a question for Valeria as well. We could see quite a few number of undergrad students students on assisting the research projects. So I was wondering which mechanisms you promote or what types of incentives you give in order to engage them on those projects. We, as you know, ExploraTec is particularly interested in the teaching, the training side for undergrads. So would you give us some perspectives on that side?
Yeah, so I've been lucky to recruit some of these students from my classes. So Shuao and Alex were straight from my classes, and I'm thinking everybody else actually, I'm thinking about it. Money is always good because when you pay a student, it gives them the ownership of the project. And in some cases, I also been able to give them credit for research. We have independent study. It's called EME 199. It's a course where you can do a research project. You have to commit to a number of hours. So for example, Fernando, who did all the aerodynamics research for this turbine, he got 4 credit hours worth of units for his undergraduate degree. And he wrote a report that was just excellent. It was actually a lot better than a lot of the master's thesis that I reviewed. So I think many times the projects, because they're kind of out of boundaries, resonate with students who are interested in more than just one discipline. And that gets them in, and then you basically try them out. And then when you can, you reward them this way.
Thank you. Una última pregunta, creo que acá había una o ya no. Ya estamos, sí. No sé si hay un espacio para una última pregunta, si alguien tiene.
I have a question, and I'm putting Valeria on the spot. So I think about wind turbine blades made of mycelium, and if they're indoors and being tested and not exposed to the elements, I think they work fantastically. So I see them for interior architecture and other uses. But can you tell me what your dreaming is, since bio-based binders that are non-toxic are hard to come by? How do you think about the future of wind turbine blades with mycelium when you propose them into the exterior environment?
So my main target application is disaster relief, because what I see is having some of these wind turbine blades, for example, I think that you can probably design them up to 10 kilowatts. 10 kilowatts is the amount of solar energy I have in my house. But if you're in a situation of emergency and basically you have no power, you can have a number of these that can be boxed up and shipped. And then they can basically restore power to, a school, a hospital. And then once, hopefully, the power comes back up, then you could keep using them. Or if you don't want to use them, you put them in a compost bin. And for me, the typical scenario is Puerto Rico. I mean, they have had 2 disasters, one after the other. They've now recovered. They're pushing solar energy. It's an island. So, wind energy would be the obvious thing to do. And have these basically a technology that could have restore power faster than having solar energy on their, on the roof or infrastructure. So I like the idea of disaster relief. I also think about many rural areas. I mean, I've seen documentaries about Patagonia. That could be, I know that there are winds that will probably destroy my blades, but I think there might be definitely a niche application for wind energy. And then you don't destroy and pollute the environment when you're done. Thank you.
Bien, con esto estamos entonces terminando en tiempo el seminario junto a la Universidad de Davis. Quería agradecerle muy especialmente a ellos y también a las otras instituciones que nos acompañan en la Semana del Biodiseño y la Industria, a Cristina, a Valeria, a Fernando Rojas también, y a todas las personas que vinieron hoy día presencialmente y las que se conectaron por Zoom, VDTV, y muy especialmente al equipo de ExploraTec que apañaron y con todo, sobrecogedora la fuerza para poder llevar adelante la agenda esta semana. Muchas gracias a todos, que estén bien.